Good evening, Las Vegas, and welcome to the 5th annual Sky and Stars Driveway Edition, brought to you by the Sky Canyon community. My name is Brittany Bolduck, the event coordinator, and I am so happy to be here with our community celebrating World Astronomy Day together, yet apart. This year, we have not only reimagined the way we are doing the event, but we are also welcoming residents from across the valley to participate. I'm proud to be here tonight with Keith Caceres, president of the Las Vegas Astronomical Society, to bring you the first of its kind live stream stargazing experience. We hope you are all spending some time outdoors with family and are ready to interact in our celebration of the spectacular night sky. Hopefully, we all learned something new along the way. Deep space awaits. Please welcome the space guide, Keith Caceres.
Thank you, Brittany. Thanks, everyone, for joining us. Welcome to the 5th annual Sky Canyon and now Southern Highlands event. Really glad to be here. I wish we could be up in beautiful Sky Canyon Park in the northwest part of the valley where we usually do this event, but we're going to try something new tonight. First, I want to direct you to the western part of the sky. The western part of the sky is where the sun just went down, and you're going to see what looks to be a very bright star out there. And it's the brightest part of the sky right now because the sun just went down. And the reason we want to start in the west part of the sky is because, like the sun and the moon, all the stars rise and set. So everything in the west part is going to set soon. So we want to start over there. Before we get going, though, I want to give you a little guide on how to navigate the sky. This is how amateur astronomers often find things in the sky, especially if you have like a manual telescope. Show you my telescope, by the way. I've got that there tonight. It's not a manual telescope. I've got cameras on the back of there. So if you got a manual telescope, the way astronomers find things is they use the concept of degrees. And you can just use your hand to do this. So like if you have star charts, if you say like what you're looking for is 3 degrees left of a certain star, you can use your hand to estimate that. Start by putting your thumb out at arm's length. And that covers about 1 degree of the sky. And to give you a rough idea of that, put that thumb, cover up the moon first, and you'll see that the sun, your thumb easily covers a full moon. That's because the full moon and the sun are about half a degree. So I know they look bigger than that, but they're really not that big from an angular point of view. And remember that a circle has 360 degrees, so all around you is 360 degrees. If you wanted to look straight up, that would be 90 degrees. And if you needed to use more than 1 degree, besides the thumb, you can also use 3 fingers for 5 degrees. You could use your fist for 10 degrees. Do like a little rabbit ears here for 15 degrees. And then finally your thumb and your pinky to get 25 degrees. Again, these are all at arm's length, and that's just a rough guide. So, okay, let's look back at the west part of the sky here. And the first thing we're going to look at is the constellation Orion. Going to see 3 stars in a row, very recognizable set of stars called Orion's Belt. And I'm going to zoom out a little here. There's also a bright red star about 10 degrees from the left star of the belt. The left star of the belt here is called Alnitak. And the red star up here, that's about 10 degrees, recall that you use your fist, that's Betelgeuse. This is like one of the most recognizable constellations in the night sky. And another thing I want to mention is one of the ways that amateur astronomers and professional astronomers designate stars. So for each constellation, there is what they call the alpha star of that constellation, the beta star, and it's usually the brightest star, the second brightest. The gamma star is usually the third brightest. And Betelgeuse here is the alpha star of Orion. And these designations are called Bayer designations. They came from Johann Bayer from Germany in 1603. He tried to name all the stars by their constellation and their brightness, just kind of eyeballing it, because Betelgeuse here is actually what's called a variable star. So it will decrease and increase in brightness over time. And so it's usually the brightest star in this constellation, but Rigel on the horizon, which is probably behind the mountain for you, sometimes is the brightest star. So this one is also known as Alpha Orionis, besides being called Betelgeuse, and Rigel down here is sometimes known as Beta Orionis. And then another thing that is worth noting, Orion here is the hunter. You can kind of see his bow here, his belt. And this star pattern that we're looking at, a lot of people would think of that as the constellation, but it's actually not. If you see these faint blue borders around the sky here, that's actually that area of sky. Everything in there is considered to be part of Orion. And then this star pattern that we recognize Orion by is actually called an asterism. So the connect the dots pattern is the asterism, and the area of the sky bounded by these blue lines, that's the constellation. So I want to direct you to a neat part of the sky here. Below the belt, if you follow the belt down from Alnitak about 3-4 degrees, you'll see 3 dim stars. And this is a very famous part of the sky. Let me zoom this picture out here. This is this location over here, the center of Orion's sword. So this is the waist, and then this is his sword hanging off his hip. And if you look in the middle of that, it's not actually a star, it's actually the Great Orion Nebula, which is also known as M42 or Messier 42. Let's zoom in on that. This is the closest place to Earth where new stars are being created. This is 1,400 light years away. And
Steve, can I ask you a question real quick?
Oh yeah, sure.
How would you define to all of us exactly what a light year is and how it's determined?
Great question. A lot of people think the light year is a unit of time. It's actually a unit of distance. It is the amount of distance that light travels in 1 year. So the speed of light is 186,000 miles per second. Multiply that by the number of seconds in a year, which is a lot. You wind up with a number that's 5.8 trillion miles with a T. That's 12 zeros. And then astronomers, like amateur astronomers, like to use light years because it gives you an idea of how long it takes light to get there. So like, if this took 1,400, this is 1,400 light years away. So the Orion Nebula, we're seeing it the way it looked 1,400 years ago because it took the light that long to get here. But professional astronomers don't even use light years usually. They use something called a parsec, which is a more technical unit. It's about equivalent to 3¼ light years. But the average person, the only time they probably only heard of a parsec is from Han Solo saying that the Millennium Falcon could complete the Kessel Run in 12 parsecs. But he makes it sound like a unit of time, but it's actually also a unit of distance. So hopefully that clears up what a light year is. But 1,400 light years is really kind of like our neck of the woods. To put light years in perspective, this is a model of our Milky Way galaxy. This disk here, the spiral disk, is about 100,000 light years in diameter from one end to the other. The sun, our whole solar system, is down here. It's kind of the middle of that red splotch. And our solar system's about 26,000 light years from the center of the galaxy. So when I say it's 1,400 light years away, it's like really close. It's like right over here where my mouse pointer is. So I'm going to take you from there back to Alnitak. And I'd like you to look at a little to the right here. I'm going to look at what looks like it's the brightest star in the sky, off to the right of Alnitak there, and much higher than it. And that's about 30 degrees away, so about 3/5. We're called like each one of those is 10. And that very bright star is actually not a star at all. It's actually the planet Venus. Venus, if you have a telescope and could put it under some magnification, you could actually see it's a crescent tonight. which it has phases just like our moon. And I'll get into that later, why it has phases just like our moon, and explain the moon's phases. But what we're seeing, what looks like a star, is actually the sun's light reflecting off the daytime side of Venus. And then it's over here is just the nighttime side. I'm going to zoom out there. So Venus, sometimes it looks so bright, like it confuses people. You'll often see like a kind of that lens flare effect where like streams of light are coming away from it, especially if there's moisture in the air. It can kind of create a halo effect around it. And people get confused. They'll think it's either like a plane coming in for a landing that never moves, or you'll even get like UFO calls or UFO sightings. I get asked the question all the time, like, "What's that really bright light that's hanging out in the west?" It's just really strange. It's got all these streams of light coming off of it, and like police, aviation control towers will get calls because of it. So just remember, if you ever see a light hanging low in the sky, think about was that in the west part of the sky? Because right after sunset, Venus is usually trailing the sun, or conversely, if it's right before sunset in the east part of the sky, in the early morning, you might see Venus in the early morning, right before the sun rises, or low in the sky in the west, right after the sun sets. So if you ever see this bright light and you're wondering what it is, think about is it in the west in the evening, or in the east in the morning? It's most likely Venus. All right.
So you're confirming for us that Venus is not a UFO, right?
Yeah, Venus is definitely not a UFO, just our sister planet. Okay, from there, we're going to go 18 degrees from Venus, kind of the upper right from there. Remember, that's just a little bit short of 2 fists. And that is the alpha star of the constellation Auriga, which is also known as Capella. That's its regular name that everyone knows it by. And you can see here the constellation Auriga is this border over here, but the star pattern itself is in the constellation Auriga. And if you happen to have binoculars tonight, you might also want to take a look about 18 degrees, like draw a straight line from Venus to Capella, and you might be able to see a comet that broke up over here. Comet Atlas is getting dim. Unfortunately, we were hoping it was going to get bright enough to see with the naked eye, but the sun's heat broke it up. But you might be able to see something out there if you draw a line and search out there with your binoculars.
Keith, how could I determine what exactly a comet is if I was looking with my naked eye?
So comets, we haven't had a good naked eye visible comet in quite like over 20 years, I believe, at least in the northern hemisphere. But comets usually have that tail behind them. They got a bright center, and then they have the tail streaming off it that always points away from the sun. And they're basically dirty snowballs that usually hang out in the outer parts of the solar system. And sometimes their orbits take them close by the sun. And when the sun's heat heats up the dirty snowball, you get all these gases coming off it. And that's what makes it bright, because the gases, and the dust are reflecting the sunlight. So, but they're very unpredictable, unfortunately. So it's hard to know when you're going to get a really good one coming. All right, so we're going to head back out towards Betelgeuse. And if you look to the left of Betelgeuse, you're going to see a very bright star. It's not as bright as Venus, but it actually is a star, not a planet. It's 21 degrees left of Alnitak, the left star from Orion's belt. So remember, just a little more than 2 fists and a little bit up. And Sirius is in the constellation Canis Major, which Canis as in dog from Latin, and major as like greater or big. So this constellation here is the great dog, or the big dog. And Sirius is sometimes considered the eye of the dog, even though it kind of looks like that's the collar and this is the head over here. And you can see you probably, I don't know, if you're in a darker place, you could see his tail and his legs. But you probably can only see the brighter stars from Canis Major. But Sirius is a giant, massive blue star. quite different from our sun. Our sun is a average size yellow star, and Sirius is a really massive blue star. And what determines a star's like its color is how hot it is, and how hot it is solely determined by its mass. So a really massive star burns its fuel really quickly and burns very brightly, and it only lives like 10 million years, which is not a lot of time for an astronomical object. Whereas our sun will live about 10 billion years with a B, about 1,000 times longer. But Sirius, not only is it a brighter star than the sun, it's only 8.6 light years away. So it's really like a stone's throw away from us. Like the closest star to the sun is called Alpha Centauri, the Alpha Centauri star system. It's only 4.5 light years away from us. So Sirius is only 8.5 light years away. It's one of the closest stars. And that makes it the brightest star in our sky, both because it's inherently brighter than the sun and because it's so close. Brightest star, I should say, other than the sun, of course. But now from Sirius, you're going to want to look up and a little bit to the right. And this star here, up here about 25 degrees, recall this is about 25 degrees up from Sirius, and that's Procyon. Procyon is called Alpha Canis Minoris, the lesser dog or the small dog. So this constellation here is Canis Minor, and Procyon is the alpha star of the Canis Minor constellation. And then if you zoom out, well, I'm going to zoom out. If you look up and to the right a little, you're going to see a pair of bright stars, and the closer one to Procyon is called Pollux. It's another 22 degrees. 22 degrees away from Procyon, up and to the right, and Castor right next to it is 4.5 degrees away. Now, this constellation you might recognize from Castor and Pollux are the twins. So this is the constellation Gemini. And so again, we have this border here is the constellation Gemini. And then you could see the stick figures, which you might not be able to see in the city. But if you went someplace dark, you could recognize these stick figures. But the stick figures, the twins, the Gemini twins from mythology, are the asterism here. And then you have Castor as the alpha star of Gemini, also known as Alpha Genorum. And Pollux is the beta star, Beta Genorum. And then I want to direct your attention, this is not going to show up in the sky here, but you'll see in my program here, there's a yellow line that's going up through the sky. And I'm going to just zoom out and show you that it's like an arch from the southwest to the southeast. This line has very special meaning in astronomy. It's known as the ecliptic. And what it represents is the Earth's orbit around the sun. If this is the sun, if you have the Earth going around it, that defines a plane. And that plane projected up into our sky is this line known as the ecliptic. And because all the other planets and asteroids in our solar system orbit in roughly the same plane that the Earth goes around the sun, you will notice in the sky that planets, the moon, and asteroids are always around this line. They're in the south. When you're observing from the northern hemisphere, you want a good view of the south a lot of times because you want to be able to see the ecliptic. So you'll notice that the moon is near the ecliptic. And if we had bright planets visible tonight, well, we do have Venus, you can see Venus is near the ecliptic. And another special thing about it is these constellations, you see they're all over the sky, but there's 88 constellations total. We can see 44 of them from the northern hemisphere of Earth. The other half, you have to go below the equator to look at the southern hemisphere. But the special constellations that everybody knows well are the ones that go through the ecliptic here. So this is Gemini over here. This is Cancer. This is Leo, the lion. This is Virgo. So all the zodiac constellations are the ones that go through the ecliptic. So we already looked at the twins there. And let's head over to the south We're going to see the star of the evening. It's our featured item. It's not actually a star, of course. It's the moon. So right now, when you're looking at the moon, you're looking sort of in the south part of the sky, though the moon is very high in the sky tonight. And right now, it changes all the time what constellation it's in, but tonight it's in Leo the Lion. And if you look to the right of the moon by, what do we got here, 14 degrees, you'll see Regulus, which is the alpha star of Leo. And while we're on the moon, this is a photo I snapped of it tonight with my telescope. Let's switch over to you can see my telescope is pointing live at the moon right now. I'm just going to grab it. Drink of water there. But this is a photo I snapped of the moon tonight here. You could see a lot of the crater detail. Usually when you're looking at the moon with the naked eye, you usually want to look at the full moon. But when you're looking with binoculars or a telescope, it's actually more interesting to look at a crescent moon or a moon like this. This thing is called a gibbous. So like if it were a crescent, everyone knows the familiar shape of a crescent, looks like a croissant. You get that when the moon is younger, but tonight the moon is in between what we call a first quarter moon and a full moon. It's about 75% illuminated. And this line here that you see is called the terminator. No reference there to any killer robots. But the moon doesn't have an atmosphere, so the dividing line between the daytime side and the nighttime side is very stark. And when you look at these craters on there, the sunlight is really grazing these at a steep angle, and it really brings out a lot of detail. And before I show you about the moon phases, I want to show you a live view. This is actually the view through my telescope right here. This is a live camera view. I'm going to zoom into this.
So the craters we see in your picture aren't necessarily all of the craters that are on the moon, right?
That's right. That's right. There's actually craters over here, but because the sunlight is coming down almost directly into them, you don't see enough contrast to see those craters. This is just the live view in the camera, so it's not as sharp as actually taking a photo. But yeah, you only tend to see the craters where the sun is able to graze them instead of go directly down them. And that's why it's boring to look at the full moon, because that's when all the craters, the sunlight's going all the way down directly, looking down the craters directly. But let me give you an idea of what's going on here as far as the phases. We've got a diagram. And you can see here it says sunlight where these arrows are. The sun is really far away in this scale. The sun is 93 million miles away from Earth. That's what we call 1 astronomical unit. And so the sun's way over there, and it's shining light across all the bodies that are here, which are just the Earth and the moon. And the moon has a cycle. It goes around the Earth. It goes counterclockwise in this picture. And it takes about 28, 29 days to complete one orbit around the Earth, which is about the length of a month. And that is not a coincidence. The word month comes from moon, month. And if you go back to lunar calendars, which today we use not a lunar calendar, but some cultures still use lunar calendars, and thousands of years ago they were more popular. But they were based upon the orbit of the moon rather than the the Earth going around the sun. So when the moon is in between the sun and the Earth, we call that the new moon, and that's when you can't see the moon because you're looking at the nighttime side of the moon. See, this is the side facing the sunlight, and that's bright, and the side facing away from the sunlight looks dark. But you can see here, the people on Earth would be looking at the dark side of it. So it just looks like that. Another interesting thing about the new moon is it's always around the sun. So remember, people on Earth are looking at the sun too from here. So the new moon rises around the same time the sun rises, and it sets around the same time the sun sets. And because of the sunlight making the sky blue, you really can't see the new moon besides looking at the dark side of it. So then that first week after the new moon, like just watch it after the new moon, every day you'll notice it becomes a bigger and bigger crescent. You see right here, it's going to look like that because this side is facing the sun and it reflects to the earth. And this is what we call a waxing crescent. That's when it gets bigger. It's getting bigger each day until you get to 1 week past the first moon, the new moon, which is known as the first quarter moon. Now, a lot of people want to call this the half moon, which it is half illuminated, 50% illuminated, but we call it the first quarter moon because it's gone 1/4 through its orbit. And we had that just a few days ago. So tonight's moon is over here. And when it gets more than 50% illuminated, now it's called a gibbous. And as it's getting bigger each night, it's called a waxing gibbous. So we're about here tonight. And so we got about a 75% illuminated moon. And in a few more days, the moon's going to be over here when all the sunlight streams past the earth and reflects back to the earth and people see the full moon. Then it'll get past that and it'll start getting smaller. It'll still be a gibbous, sort of like this. Now the other side of the moon will be illuminated and it'll get smaller each night. So I call it a waning gibbous. Then you get the third quarter moon over here a week later. And this doesn't rise until late in the evening. And it's a half illuminated moon, but now the other half is illuminated. And then finally, a week later, it completes the cycle and you're back to a new moon. Now, something interesting happens when you have a new moon and a full moon. The moon's orbit is actually at a different plane than the sun and the Earth's orbit. So if this is the sun and the Earth's orbit, and this is the moon's orbit, you wind up where when it's at the new moon and the full moon, you often don't have a perfect alignment. And that's why you could see the full moon in a few days and why the new moon doesn't usually block the sun. But occasionally they do align perfectly, and that's when you get eclipses. When the moon's new, you can get a total solar eclipse where the moon's shadow will be cast onto a specific place on Earth where you'll see the sun blocked out. And then when the moon is full and they align perfectly, you'll have the Earth's shadow cast onto the moon and you'll get a total lunar eclipse. One more thing I want to say about the full moon is another neat thing about that is it rises when the sun sets. So if the sun goes down, the moon's coming up when the moon's full. And when the sun comes back up, the moon will be setting. Because as you can see, they're 180 degrees separate from each other in this diagram. They're going to be 180 degrees separate from each other in the sky. All right. Now, I'm going to direct you to look behind you. So right now you're facing the moon. You want to look to the opposite side of the sky, which is going to be north. And the most recognizable thing in the sky on the north side is the Big Dipper. And you're going to see the Big Dipper is going to be pretty darn high tonight. It is way up there. I got too many lights in my eyes to see the stars very easily. Okay, so you're going to see Big Dipper is going to be about, how many degrees above about 45 to, about 50 to 60 degrees above the horizon, probably about 60 degrees above the horizon. And of course, all the stars in the Big Dipper are easily recognizable. You can see this is the pot over here, and this is the handle. And this is in the constellation Ursa Major. You can see again the blue border. A lot of people might call the Big Dipper a constellation. It is not. The Big Dipper is in the constellation Ursa Major. Ursa meaning bear, and major again meaning greater or big. So you could kind of see this. If you probably can't see live that these dimmer stars look like a bear's head over here, but that's where it gets its name. It kind of looks like a bear's head. But the Big Dipper also lets us see the North Star. So if you find these two end stars from the Big Dipper, they're known as the pointers. And if you draw a line from them, this is Merak and this is Dubhe, and 28 degrees down from them is Pollux. Excuse me, not Pollux, Polaris. And Polaris is called that because it's the pole star or the North Star. All the stars in the sky look like they are revolving around it because it happens to be very close. If you were to project the Earth's North Pole up into the sky, it's very close to that just by coincidence. And if you were to take a long exposure photo of the North Star, whoa, what is that doing? All right, let me open that up directly. Trying to show you a photo. There it is. I don't know why it wouldn't open in my little photo browser. So this is a photo I took at Cathedral Gorge State Park, about 200 miles north of Las Vegas. And you have to go to a dark place to do this because the city lights will ruin this if you try it. You need a camera with a manual mode where you can do a long exposure. And I just put my Canon 70D on a tripod, pointed it at the North Star, and told it, put it in bulb mode, just told it to open the shutter, let it go for 10 minutes, came back to it, closed the shutter. And you can see here in that 10 minutes, the exposure, the North Star pretty much stood still. The North Celestial Pole is about over here, and the North Star is very close to it. You could see it elongated just a little bit in that 10 minutes. But you could see the further stars are from there, the more they look like they are moving. Of course, the stars themselves really aren't moving. It's just that we live on a spinning planet, and this makes the stars look like they're moving, but it's really we're witnessing the Earth's rotation. And if you were to like zoom out more and more from the North Star, these circles, these counterclockwise circles of the stars going around it, get wider and wider and wider, and that's why things rise in the east and go over in a big arch, and they set in the west. Things that are very close to the North Star, though, they never rise or set. They're called circumpolar. They just go around the pole. But yeah, if you get out to the east, then these circles get very wide, and you can see things rise and set. Okay, so we're going to go back to the North Star, or excuse me, back to the Big Dipper.
Keith, I have a question about the Big Dipper.
Oh, sure.
So does the position of the Big Dipper change? Like sometimes it looks upside down, sometimes it looks right side up?
That's a great question. Yes, it absolutely does. So Big Dipper is one of those things that's nearly circumpolar. It is going to travel over the course of the night. Right now it's very high, but it's going to make this circular path down to here as the night progresses. But in different parts of the year, it can actually be just below the horizon or below mountains or trees where you can't see it. And if you wanted to find the North Star then, you can't see this tonight because it's low, but there's this lazy W constellation that's known as Cassiopeia. And it's not as directly pointing at the North Star as the Big Dipper does, but that W shape is always open towards the pole star. When the Cassiopeia is high in the sky, you can kind of think of this left part of the triangle. You could draw a triangle with that left part of the W, I should say, and then like kind of draw a line between it, and that kind of points to the North Star. So yeah, sometimes Cassiopeia will be high and the Big Dipper will be low. When it's over here, it'll be pointed to it's always open towards the North Star. Oh, one more thing I want to say about the North Star. It's the end of the handle of the Little Dipper. And this constellation is Ursa Minor, the small bear or the lesser bear. And you can see here in the sky, unfortunately, the other stars of the Little Dipper are pretty dim. So you can't see those easily unless you go to someplace dark out in the desert. But the only bright star in that constellation is Polaris, the end of the Little Dipper's handle. So you can see here the Big Dipper is kind of emptying into the Little Dipper. Okay. And there's one more thing you can do with the Big Dipper that is pretty neat, besides pointing to the North Star, is you could follow the handle here. Look at the arc that's in this handle and sort of continue that arc until you hit a big bright red star. And that star is known as Arcturus. And that is the alpha star of a constellation known as Bootes, Bootes. And that is another red supergiant star that's kind of near the end of its life. So take the Big Dipper, you arc to Arcturus, and then drive a spike to Spica. Just go straight over to the right here, and Spica is about 32 degrees from Arcturus. And I should say that Arcturus is about 30 degrees from Alkaid, Alkaid being the last star in the handle of the Big Dipper. So you got about 30 degrees here, and you got about 32 degrees here. And Spica is the alpha star of the constellation Virgo. Notice we're back at the ecliptic now. So this is going straight through the constellation Virgo, and Spica is Alpha Virginis. And then I did want to show you one last astro photo before we conclude and take some questions. So if you have binoculars, this object is binoculars, and of course with a telescope, you could see this object with binoculars. So look at the end of the Alkaid, or the end of the Big Dipper, and Arcturus. Think of that as like the base of a triangle. And over here, about halfway down to the, in between them and about halfway down to the horizon, we have what's known as M13, the Great Globular Star Cluster in Hercules. And I've got an astro photo of that. Let's see if this photo browser wants to work. I don't know why that doesn't, but I'm just going to open up the photo directly. Okay, there we go. This was taken with my telescope, and let's switch over to it. And this object, in the very center of it, you can see that very bright center with binoculars. This is about 400,000 stars clustered together in a tight ball. And these things, what they think they are is, I'm going to just go back to my galaxy model here. When you look at a galaxy, most galaxies have these things called dwarf galaxies orbiting them. That's what these little dots are. They're not stars, they're dwarf galaxies. And what some astronomers think that these globular star clusters are is a very small dwarf galaxy may get too close to its host galaxy or try to pass through it, and its gravity could steal its star creation gases and just leaving this little tight ball of stars in the center of it. And every galaxy pretty much has a tight ball of stars in the center. Of course, full-size galaxies have a much bigger cluster of stars, but they think that these are just little balls of stars left over from dwarf galaxies that can orbit this disk. They can orbit the center of our galaxy at any angle. So when you look at a globular star cluster, you are looking up off our disk. Most of the stars are on the disk, like our sun, but these are very old stars that are off the disk. Okay, any questions?
So I think let's give them a minute to send their questions in. Thank you so much for joining us. We are always so thankful to have the Las Vegas Astronomical Society as our partner. And we look forward to many, many more years with you guys. And hopefully next year we'll be back out at the park at Sky Canyon, enjoying the night sky all together. But I did want to ask you, for our listeners that would be interested in purchasing telescopes or binoculars, if there are some that you suggest and the best places that you suggest for them to go and purchase these to start off.
So yeah, there's a lot of great vendors. Some of the ones I like, there's one here on the West Coast called Agena Astro. There's OPT, which is Oceanside Photo and Telescope. There's also Astronomics, which is more towards the Midwest. I'm probably forgetting a few. There's also, I gave you an example of a small telescope. Oh, Orion's another good one. They're a good vendor. But I tend to recommend like in the link for the event, there's one I mentioned, it's off of Amazon. That's a good telescope too. It's from a company known as Zoomel, and then there's other ones that size. What that is a little 5-inch tabletop reflector. And by 5-inch, I'm talking about the diameter of the mirror at the bottom of the tube. and that's known as the aperture of the telescope. That's really important. That determines how much light you can gather and focus, and it determines how dim an object you can see. And those telescopes, you could fit them on a tabletop, just point them manually. They're really easy for kids, and 5 inches is a good starter size to see quite a bit with. They're about $200, $199. Orion makes some like that. Meade used to make one, but they discontinued it. That Zoomal one is one. It's 130 millimeters, which is about 5 inches. That one that I've gave you the link for. And then the other one is you can do quite a bit with binoculars too. Binoculars are a great way to start off with astronomy, and they give you a nice wide view. I like these here. I don't know that they have these anymore. But the ones I give you a link to are made by Orion. They have a nice wide field of view. You can go someplace dark and scan the sky with them. You could see very bright objects like the Orion Nebula and M13 that we saw tonight. So yeah, I do recommend those. Pretty much 5-inch and 6-inch Newtonians are generally where you want to start with, or 8-inch, depending on your budget. But if you want, I would recommend not spending less than around $200 on a telescope. Usually the ones below $200 tend to be high on the frustration factor.
Great, thank you. So I think we had a couple questions come in. The first one is, when you see a shooting star, is it really a star burning out, or is it falling?
It is falling, but it's not a star at all. It is actually a little pebble-sized meteor. Shooting stars are just meteors. And when you see meteor showers, you're basically seeing Earth travel through the tail of a comet. So I mentioned before, comets, they have weird orbits. So Earth basically takes a circular orbit around the sun. And comets have these really weird oval orbits that look something like this. And sometimes they cross the Earth's orbit and they leave behind this trail of dust and debris. And what happens is the Earth slams through that dust and you see all these little pebble-sized objects. Sometimes they're bigger, but the typical meteor you see streaking through the sky is a pebble burning up in Earth's atmosphere, from usually left over from a comet, possibly an asteroid. And when it's bigger than a pebble, then you see things like fireballs and stuff that can really light up the sky.
Speaking of comets, one of our viewers is asking if there is a comet shower upcoming and if that's something that we can predict.
There is. I'm sorry, I can't remember the name of it, but there is one coming up. I think it's within a week or so, and I can get the name in the comments later on. It's one of the lesser ones.
Perfect. And then what type of binocular strength is advisable?
So I prefer, for starters, these are what they are called 7x50s. And 7 refers to the magnification, and 50 is the diameter of the lens that you see in here. So again, I'd mentioned aperture before with the telescope as a 130 millimeter mirror. Well, refractor telescopes, you could kind of think of this as 2 refractor telescopes. And this here, the lens, the objective lens, is 50 millimeters. So that's going to determine how dim of an object you could see. So 2 50 millimeter lenses and 7 magnification, 7x50s, or 10x50s are good too. That's 10 magnification and 50 millimeter lens. I don't recommend much more than 10 magnification unless you have a tripod to mount it on, because trying to hold it steady with the movement of your hand, the more you magnify it, the more it's going to magnify the movement of your hand, and it's going to make the image jumpy, and it's going to get frustrating without a tripod. So handheld, 7x50 or 10x50.
We have third grader Grayson asking, if the sun were to increase in size, would our days be longer?
So our days are determined by how long it takes the Earth to rotate. It takes the Earth 24 hours to go all the way around, make one complete revolution. And the side of Earth that can see the sun, it's only day it's day for you when the Earth is pointing towards the sun, which is about almost 12 hours out of the day, depending on what year. So, what part of the year. So if the sun were bigger, it wouldn't make the day any longer, but it could certainly make the sky brighter. And the sun actually will get bigger as it runs out of fuel 4 billion years from now, very, very long time. The sun will get gigantic. It'll become what's known as a red giant, and it will engulf Mercury, Venus, and maybe even engulf the Earth. But again, it's nothing to worry about because it's a very long time for now.
We had a couple of questions asking what stars and comets are individually made of. So maybe if you could explain the difference between the two.
Sure. Comets are much smaller than stars. They are just dirty snowballs. They're frozen gases. They're usually they could be frozen water. They could be frozen carbon dioxide, which if here on Earth, if you go to the store and get dry ice, that's frozen carbon dioxide, and they're usually stuff like that, methane, frozen light gases in water, and they usually hang out in the far reaches of the solar system. Stars are very, very different. First off, they're gigantic compared to comets. But stars, like after the Big Bang, most of the gas in space was hydrogen and helium. As the Big Bang occurred, the atoms that were formed were hydrogen and helium, about 75% hydrogen, 25% helium, and then every other element is just considered a trace contaminant, and those weren't around in the beginning; they were created by stars. So stars are areas in gas clouds, like let's go back to the Orion Nebula because that's where star creation is happening. Oh, this is. Let me go back to Orion M42. So this is where stars are created. And so here you have an area of hydrogen and helium gas that's come together and under its own gravity, kind of the gravity's pulled it together, and you wind up with areas inside here that are really like slightly denser than the surrounding gas. And over the course of millions of years, because they're slightly more dense, they have more gravity and they pull in the gas around them. So over millions of years, it's just packing in more and more gas until it gets to a critical amount of mass. And I don't know if you know it. It's not maybe not common knowledge, but the more gas you pack together, the higher the pressure gets in the center of that gas. And as the pressure goes up, the temperature goes up. So at the core of what we call a protostar, these gas pockets, you have the temperature going up for millions of years. It's like 1 million degrees Fahrenheit, 5 million degrees Fahrenheit, 10 million degrees Fahrenheit, and then something special happens around 15 million degrees. That ignites what's called hydrogen nuclear fusion. And this is what's happening in the center of our sun. You have hydrogen atoms slamming together at such a high speed. They're actually not atoms anymore. It's so hot that it's just the nucleus of the atoms, which is protons. And they slam together and they stick together, and that makes a heavier version of the element. When you get 4 of those together, you get 1 helium. So right now, the core of our star is converting hydrogen into helium, and it releases a tremendous amount of energy through this process called nuclear fusion. And stars, when they're on the longest part of their life, it's known as the main sequence. That's when they're burning hydrogen to make helium. But really big stars, our sun can, later in its life, when I mentioned it runs out of fuel, it'll swell to be a red giant. That's when it starts making carbon out of helium, and that's as far as it can go. It's not a very big star. But I'd mentioned Sirius earlier, the big blue stars. That's actually where you get heavier elements. That one later in its life, it can fuse carbon into things like oxygen and nitrogen. And it can go all the way up to iron. And then when a star starts making iron in its core, it only has moments to live, and it goes supernova. And that supernova explosion generates elements that are heavier than iron, things like gold, silver, platinum, lead, uranium, plutonium, those kind of things. All the heavy elements, they only typically get created in either supernovas or certain heavy star collisions. So stars
Right.
are very different than comets.
Right. Seventh grader Katie has asked if a star inside of a big cluster blows up, does it affect the stars around it?
Surprisingly, it really doesn't. It really depends how far away. But there's been cases I've seen where professional astronomers have documented binary stars. That's two stars that orbit each other pretty close. And most of the stars you can look up and see, a lot of them are actually double star systems, binary systems. And there's been cases where one will go supernova and leave behind a stellar remnant, and the other star, I'm sure it will blow away like a portion of its material, and maybe the outer atmosphere of the star will get blown away, but you will see like things like a neutron star or black hole being orbited by another star, and to have a neutron star or a black hole, that means at one time there was a supernova there, and it didn't blow away that other star. So it'll definitely blow away some of the material, but it won't destroy a star most of the time.
We have a 4-year-old kindergartner with us, and Justin, is wondering if you could explain to her what an astronomer is.
That is a great question. So a professional astronomer is, astro just means star. And so astronomy is the study of the stars, study of the sky. It's a scientist. It's the very first field of science, by the way, is because mankind looked up at the sky and tried to understand it before really trying to understand the rest of nature. So it's like the first field of science that mankind devised. And it's really the study of the stars and the study of things out in space.
Thank you for that. And then we also have someone wondering, they're viewing the sky with their naked eye, and they're asking what is behind the stars that we can see, what continues on past that.
So that's a pretty neat question. The simplest answer is more stars. I'm going to show you a kind of an interesting. I'm going to show you an interesting app here that kind of illustrates this point. So this is the same app I had running on the computer, but this version is actually a little better. It does something that I want to show you. Oh, I wish I had it ready. I want you to Google, when you get a chance, the Hubble Ultra Deep Field. Here we go, finally. All right, sorry for the delay there. Hopefully doesn't look like it's too blown out. So there's a model of our solar system, and if you keep scrolling, zooming out on this, I guess this isn't showing up so great. Oh, there it goes. So if you zoom out from our galaxy, and you could see all these other galaxies, and then you could kind of see this cone thing here that's coming away from there. I wish the visual is so much better when you're right up on top of it. But what this is NASA took the Hubble Space Telescope and they pointed it in a very dark part of the sky where they've never seen any foreground stars from our own galaxy, and they haven't ever seen any nearby galaxies. It just looked like a very, very black part of space. And they took a picture, they added up 1 million seconds of camera exposure time. And that is about 11 days of camera exposure time. And when they got done, they had this picture that was just full of the most distant galaxies they'd ever seen, out to about 30 billion light years. And so no matter how far out you look into space, you're eventually going to hit some other galaxy. And a galaxy is really just a conglomeration of stars. Our galaxy here, this is a model of our galaxy. This disk contains probably between 200 billion and 400 billion stars. So when you can't see a star there, it's just because your eye can't see it. Like, the parts of space that look black, you can't see something there. But if you go out far enough, you're going to go and you're going to hit another galaxy, and that a galaxy is made of millions or billions of stars.
That is so interesting. We have a 4th grader asking if we can see the International Space Station.
You absolutely can, and there's websites you can go to that are dedicated to telling you when it's going to come overhead. So any night you go out, even in the middle of the city, but especially if you leave town, go out in the desert and look up, you'll see these unblinking white lights that just kind of cross the night sky. And those are satellites. And one of the brightest satellites you can see is is the International Space Station. You can easily see it crossing. Sometimes you get a really good pass. It'll like come from one side of the sky and just be bright the whole time. It takes a couple of minutes or 90 seconds or 100, about 2 minutes to pass over sometimes. It's really nice. One night we were out at Red Rock, and my friend Steve, he has a manual telescope. They're called a Dobsonian telescope, or just Dob for short. It's a big reflector telescope. And somebody was looking through it, and he was tracking the International Space Station with it while they're looking through there. And they said they could see the solar panels. And I've seen even like my friend David, he's pointed his camera. Again, there's websites that tell you when the International Space Station is going to go in front of the moon or the sun. So he pointed his camera at the moon on a night where he knew from a certain location that the International Space Station would cross in front of the moon. And he's got this great picture where you could see it just goes across the moon in about 1.5 seconds, zooms across it. But if you zoom in on it, you could see kind of this H shape of the solar panels with the space station connecting in between.
That is so cool. Let's do a couple more questions. We had a question if there is really such thing as a black night satellite.
Black night satellite? I think what they're trying to ask is if the satellite is painted in an anti-reflective coating. So I've never heard of anything referred to as a black night satellite, but what I think they're saying, you see, when you see the satellites, these unblinking white dots just go across the sky, what you're seeing is sunlight reflected off parts of the satellite, usually the solar panels or antennas and stuff like that. And sometimes they just put them up there, they don't care to make them invisible. But if you painted them with an anti-reflective coating, something that wouldn't reflect much sunlight, then it would be a nearly invisible satellite. It wouldn't surprise me if they did that with like spy satellites or something like that, that they wanted to keep them secret and keep them not easy to observe. But and in fact, Elon Musk's company, SpaceX, is putting up all these Wi-Fi type satellites up there. I think it's called Starlink. And they're putting up a ton of them. And it actually caused a big concern for professional astronomers and amateur astronomers because they're going to put thousands of them up there. And some nights you could see like a train of them after they launch. And so they are working on painting those with an anti-reflective coating so that it doesn't ruin pictures taken by professional and amateur astronomers, especially the professional ones. You don't want some billion-dollar observatory trying to expose a distant galaxy or some black hole or something like that, and you have a whole bunch of satellites marching through the image, reflecting light into the picture. So certainly nice to have satellites painted anti-reflective dark colors like that.
Great. Well, I think with that, we will call it a night. And again, thank you so much, Keith, for your partnership and your passion for astronomy. And for all of those that are still listening, you can visit our website at skycanyon.com/stars. And Keith has been so kind to share his favorite binoculars and telescopes and some stargazing apps with you guys that are all shared on there, as well as we will make sure that this presentation is posted on there if you guys want to revisit it. So yeah, with that, I hope everyone has a good night, and thank you guys so much for joining us for our 5th annual Sky and Stars Driveway Edition.
Thank you too for all your support of our club all these years.
Absolutely. All right. Good night, guys.
Bye.